Hi there, my name is Kathleen with the Houston Museum of Natural Science. I've got a fun fact for you today, and that is that the center of Earth, its core, is about the same temperature, if not hotter, than the surface of the sun. What's really cool is that we can't actually take direct measurements of either of these things. So that might have you wondering, how do we know what we know? Well, there's two very different methods. So to get the temperature of the center of the Earth, what we're actually looking for is right here in what we call the outer core. So that is liquid iron. And the reason that we know it's liquid and that it is iron is from seismic waves. So whenever an earthquake happens, those waves will penetrate farther than we could ever drill. And so when those waves come back, it tells us the density of certain materials, so what it is and whether it's liquid or solid. So when we recreate some of these conditions in the lab, we can actually say with some fancy math at what pressure and temperature those iron molecules will remain a liquid. So that gives us that 10,000-ish degrees Fahrenheit, which is about 5,500 degrees centigrade. Now, to get the temperature of the surface of the sun is quite a bit different. So for that, we use something called spectroscopy. And that involves the range of what we call the electromagnetic spectrum. So as you can see, it spans a lot larger than what we can observe, which is just right here, what we call the visible spectrum. So depending upon what kind of elements certain stars are made out of will affect its color, but that also can tell us the temperature. So for example, our star is a white star, which means that it is hotter than something like a red giant, but it is cooler than something like a blue dwarf. So you can kind of see how those colors already come into play. Now, I have a cool activity craft for us today, and that is actually to make your own spectroscope. So you can break down those different light waves, and just like looking at the stars, by breaking it down into its individual components, it can tell us a lot about that particular light source. So, in order to do this, you are going to need some dark construction paper. Right here I actually have black cardstock. It works really well. You're going to need a paper towel tube or a toilet paper tube. As you can see, I've painted the inside of mine black, just with regular acrylic paint. For tape, I have chosen black electrical tape. And the reason all of these items are a dark color is because black in particular will absorb light, which means that while we're trying to focus that light, there's nothing extra bouncing around in there. This gives us, we're gonna call it a clean canvas for our particular project. Now, some more specialized materials that we are going to need is an X-Acto knife. We also have something called a diffraction grating film. Now, this is something that we purchased from an educational source, but if you can see, it basically breaks down that light into a bunch of tiny prisms. So as that light is coming in, it's being bent. And so that is what allows us to see what we call a rainbow. So all of those different colors in their own little lane. Now, you don't have to buy this from Amazon or anything, though you can. It can also be found inside of a DVD. So I have one here. It's an old DVD. Don't grab something that you're going to want to play because we're actually going to cut it. So the way a diffraction grating film works is that it's got thousands of microscopic little grooves that act as those prisms. So we can actually just utilize that from our DVD here. And if you watch, DVDs are very conveniently broken into these two main layers. So once you cut it in half or slice it down, it should very easily come apart for you. And what we're actually interested in is this transparent bit right here. So I've done this with another DVD previously. I've already cut out the piece that I'm gonna need. So to do this at home, you might need a grown-up, and that's okay. First thing you're going to do is take your tube, trace around it so that you end up with two circles. I've pre-cut mine here for time's sake. So two dark circles, and these are going to cover either end. Now, both ends are going to have two different things going on. One is going to have our diffraction grating in it. So here I've already cut and taped, I've sized it so that, again, for time's sake, it's pre-done, but you can see what the final product looks like. You just cut out a little square, tape it on. And then the other end is going to need a slit. So it's a teeny tiny slit, really no more than 1 millimeter or so. And the reason that it has to be so small is because we are limiting the amount of light that's entering into our tube so that it's not overwhelming and you get a clearer picture. So once we have that slit and our diffraction grating film ready, all you have to do is tape it around the outside. What I like to do is snip it so that it folds over a little bit nicer. As you can see, it's never going to be perfect. But I made this out of the exact same materials. And I've got one right here for the camera if you would like. But whenever you look through, you're going to point your slit at your light source. And what you want to see is 2 rainbows, so the spectra, on either side of the slit. So you want to line it up so that it breaks down into those individual colors. So whenever you take a look at it, that's what you're going to do. So you may have to twist this particular grating layer so that it lines up. And at that point is when you will go ahead and tape it on so that it doesn't move around on you. And that is how you make your very own spectroscope at home. Take a look at different light sources. It could be an LED light, a halogen light. I especially encourage you to go outside and not look directly at the sun, but compare and contrast. So those different elements, those different lights are going to have different bandings on these spectroscopes. So yeah, you too can do science.